The Perfect Deicer, Effective and Eco-Friendly by Grace Fiedler. For my honors chemistry project, I tested which deicer was the most effective and environmentally friendly. I got the idea to do a deicer-based project from the idea sheet, and I wanted to see whether sodium chloride, calcium chloride, magnesium chloride, or potassium chloride melted the most amount of ice in a container with 250 milliliters of ice, 500 milliliters of ice, and 850 milliliters of ice. During the research phase, I needed to learn the characteristics and pros and cons of each deicer. I also needed to learn the pros and cons of each deicer in the environment. First, calcium chloride is exothermic, allowing it to melt until a temperature of -31 degrees Celsius. It is very expensive, but since it is effective, it can be used in smaller quantities and is ultimately cheaper. It also causes roads to corrode and metals to rust because of the chloride content. Next, magnesium chloride is exothermic, but 53% diluted with water, meaning it has to be used in larger quantities. And it is also expensive, causes the roads to corrode, and has a negative effect on plants when overused. On the other hand, potassium chloride is endothermic, causing it to only work until a temperature of -3 degrees Celsius, and it has a low melt volume capacity. It's beneficial to plants, but it causes corrosion to the roads because of the chloride content and is expensive. It's also often used in a blend of several different deicers. Sodium chloride is also endothermic and only works until a temperature of -6 degrees Celsius. But it is easy to access and inexpensive, which causes it to be very popular. It also causes corrosion and rust because of the chloride content, and negatively affects water supplies, soil, and vegetation, and local wildlife. These are the materials I used during my experiment, and my hypothesis states that if I melt a thin, medium, and thick layer of ice with the calcium chloride, magnesium chloride, sodium chloride, and potassium chloride deicers, then the sodium chloride deicer will effectively melt the most ice. This is my procedure. Here are a few images of me completing my procedure. Here is my graph and a few of my data tables. In the end, I did not support the idea that the sodium chloride deicer would be the most effective and eco-friendly because it did not melt the most amount of ice over the course of 15 minutes. From the beginning, the calcium chloride deicer excelled and consistently melted the most amount of ice in each trial. Throughout the experiments, the magnesium chloride deicer consistently melted the second greatest amount of ice, while the sodium chloride deicer consistently melted the third greatest amount of ice. Lastly, the potassium chloride deicer melted the least amount of ice in each trial. Since the calcium chloride deicer is very effective and can be used in smaller quantities, it lowers the cost and corrosion, which also makes it more eco-friendly. Overall, the data I collected during my experiment supports the idea that the calcium chloride deicer is the most effective and eco-friendly because it had the most consistent and fastest melting rate. During my experiment, I had two errors. First, an error occurred while freezing my ice. I used a freezer to freeze my ice, but as I continued my trials, I noticed that the longer I let the ice sit in the freezer, the less the ice would melt, possibly affecting the average for each amount of ice. Second, an error occurred in how I was measuring which deicer was the most effective. In the beginning of my experiment, I planned to measure which deicer was the most effective by seeing which deicer melted the ice the fastest. But the ice did not completely melt, so I decided to measure how much ice was melted by pouring it in a beaker with measurements. Next, I could have improved my experiment by giving the deicers less time, which would have simulated a real-life situation more. Last, I could have extended my experiment by having the same amount of ice in each trial, but use a different amount of deicer in each trial.